Hey there, Kipsters. We are looking at 7th grade practice CST, looking at questions 26 through 30. Starting with 26, a train traveled at an average speed of 45 miles per hour for 2 hours and 30 miles per hour for 3 hours. So just like the last problem, I see two rates. Rate 1, 45 miles per hour. Rate 2, 30 miles per hour. So I can see that again, this is a type 4 problem because it has two different rates, which means I need to write two different proportions. First proportion, 45 miles per 1 hour for 2 hours. How many miles will that be? Second proportion, 30 miles per hour for 3 hours. How many miles will that be? I could cross multiply or divide, or I could just kind of do this mentally. I know I need to multiply times 2 to get from 1 to 2. So I multiply times 2 here. 45 times 2, x would equal 90 miles, because that's 45 times 2. For the bottom proportion, I know I need to multiply times 3. 1 times 3 is 3, which means I need to multiply times 3 here. 30 times 3, y also equals 90. So the first part, he goes 90 miles. The second part goes 90 miles. So what was the total number of miles that he traveled? If I add those together, I know in total he travels 180 miles. Moving on, question 27. Bananas are on sale for the price of 3 pounds for $1. So again, 3 pounds should equal $1 on the graph. Which graph shows the relationship between the number of pounds of bananas bought and the total cost? So I'll do this one at a time. If I'm looking at A, I have number of pounds on my x-axis. If I go to where 3 is, here's 5, here's 0. 3 is probably about here. And if I go up, this looks pretty close to 3 pounds being equal to $1. So I'm thinking that the correct answer is A. I'll test the other answer choices just to make sure. If I look at B, 3 pounds is about here. If I go up, this graph is showing that 3 pounds is about $3. That's not the relationship I want to graph, so I know it's not B. If I look at C, here's 3 pounds. If I go up, this graph is showing that 3 pounds is maybe closer to $6. That's more expensive and not the relationship I want to graph, so it's not C. If I look at this one, if I go to 3 pounds and go up, this one again shows that 3 pounds is equal to $1. And remember, the relationship I wanted to show was that 3 pounds equals $1. So this graph actually fits that 3 pounds equals $1. The problem is, if 3 pounds equals $1, that means 6 pounds should equal $2. And for this graph, 6 pounds still equals $1, and that doesn't make sense. For this relationship to continue, 3 pounds costs $1, 6 pounds costs $2, and so on. That's what it should look like. So it's not D. The correct relationship graphed is A. Moving on. 28. The distance a string stretches varies directly with the force applied to it, so we're talking about direct variation, which tells me I'm going to use a proportion. If a 7-pound weight stretches a spring a distance of 24.5 inches, how far will the spring stretch with a 12-pound weight? So I can write a proportion that says 7 pounds will stretch it 24.5 inches. And I want to know if I put a 12 pound weight on it, how many inches will it stretch? So I'll cross multiply and divide to solve this proportion. 7 times x is 7x. 24.5 times 12, I can't do mentally, so I'll do over here. 12, 24.5. 2 times 5 is 10. 2 times 4 is 8. Plus 1 is 9. 2 times 2 is 4. Skip a spot. 1 times 5 is 5. 1 times 4 is 4. 1 times 2 is 2. Add them up and I have 0, 14, 9, 2, 2940. I need to move my decimal one place since I moved it one place in the factor. And so I have 7x equals 294. Now I divide by 7 and divide by 7 to solve for x. 294 divided by 7 will be my answer. Before I solve, I already know a couple things. I know that 294 divided by 7 is not going to be 294, so I can cancel that. And I also think that it's going to be much bigger than 3.4, so I can cancel that. It's going to be one of these two. 294 divided by 7. 7 goes into 2 0 times. 7 goes into 29 4 times. I'll divide. 29 minus 28 is 1. Bring down the 4. 7 goes into 14 2 times. Perfectly, so my answer is 42. X equals 42. And so what this means is if I put 12 pounds on that spring, it's going to stretch 42 inches, and my answer is C. Moving to 29. Mr. Calloway needs to purchase enough grass seed to cover a 3,000 square foot lawn and a 3,000 and 4,200 square foot lawn. If 40 ounces of grass will cover 24 square foot lawn, how many ounces does he need to seed both lawns? So first thing, looks like this guy has two lawns, one that's 3,000, a slightly bigger one that's 4,200. So in total, I can see that he needs to cover a total of, if I add those up, 7,200 square feet. That's me adding the two plots of land of 3,000 plus 4,200. And I know that if he uses 40 ounces of grass seed, it'll cover 2,400 square feet. So I can write a proportion to solve this. 40 ounces will cover 2,400 square feet. That's really like a rate. And I want to know how many ounces will he need to cover 7,200 square feet. And so the very first thing I do to solve this proportion is I know that I can really simplify this by saying, okay, 40 over 2,400 over equals blank over 7,200. I can just divide everything by 10. And this is 4 over 240 equals x over 720. And I'll cross multiply and then divide. 4 times 720 equals 240 times x. That's 240x. 4 times 720 equals 2,880. And if I divide by 240, my coefficient cancels, and x equals 12, which I know would really be 120 because of that trick that I used. Even if you didn't use my trick and you actually did 40 times 7,200 divided by 2,400, still would have gotten the same answer. And if you solved that proportion, your correct answer should have been C, 120. Last question for this video. Mr. Ogata drove 276 miles from his house to Los Angeles at an average speed of 62 miles per hour. His trip home took him 6.5 hours. How did his speed on the way home compare to his speed on the way to Los Angeles? So the first thing I notice about my answer choices is they all say about. So that tells me that I can estimate. So even though there's a decimal here and a big number that isn't easy to divide, I can actually round this. So what it looks like is that this guy's going to Los Angeles, or this guy's going from Los Angeles to his house, and on average he went 62 miles per hour, but for one leg of the trip it took him 6.5 hours. So I want to figure for one leg of the trip, if he went 6.5 hours, about what his speed was. So in order to do that, I'll say, okay, 276 miles is about 280 miles, and 6.5 hours is about 7 hours. So his trip home took him about 7 hours to drive 280 miles. If I simplify that, that's about 40 miles per hour. So one leg of the trip, just his trip home from Los Angeles, he went 40 miles per hour. The question's one step further complicated because it's not asking how fast did he go for his trip home. It's saying how did his speed on the way home compare to his speed on the way to Los Angeles. So if he went 40 miles per hour from Los Angeles to get home, and his average speed was 62 miles per hour, it sounds like he went a lot slower going home than he did going to Los Angeles. So how did his speed on the way home compare to his speed on the way to Los Angeles? His speed going home of 40 miles per hour is about 20 miles, oops, not faster. It's about 20 miles per hour slower than his speed of 62 miles per hour going to Los Angeles. So this is his trip home. This is his trip to LA. He went about 20 miles per hour slower going home. And D is the correct answer.